At the Southwest Louisiana Crime Lab, analyzing DNA evidence takes a little longer than you might think. DNA analyst Rhalie Austin shows the first step, which is testing clothing and taking samples.
I will be working an item of evidence from a made-up case. I made it up to be where it is a sexual assault case, and we're going to be screening the shirt for blood and semen.
Getting the evidence.
What we'll be using to screen for the blood, we'll be using phenolphthalein test, and what it does is I'm going to take a swabbing of a type of sample that I suspect to be blood, and then I will put a drop of the phenolphthalein solution onto the swab, and what it does is the phenolphthalein reacts with the heme group, the iron in the blood, and once I add the hydrogen peroxide, the positive will show pink, and then the negative will show no color change. Then what we'll do is we'll look through the alternate light source to screen for possible semen stains on the t-shirt. And then what you'll do is you'll take your cuttings of your suspected semen stains, and then we'll add them to test tubes. And then once we've done all of our cut our samples of our suspected semen stains, we'll add a solution of a buffered solution, and we'll incubate it at 36 degrees for 30 minutes. And then what we'll do from there is we can actually look on a slide. We can make a slide and look for actual sperm heads.
This is the DNA extraction and quantification room. It's not just a cut and you get an end result right away, like a lot of times you see on television. When we first get DNA samples, we have biological material on a piece of fabric, on a swab, a cigarette butt, whatever we may have. We need to get the biological material off of that substrate, as well as break those cells that are in the material open, releasing just the DNA. We end up with just a final product of DNA sample in solution, and it's just a very minute product, approximately 50 microliters of sample. The next step of the process is the amplification process. Amplification takes place by PCR or polymerase chain reaction, which allows us to take a very small sample of DNA, add synthetic DNA pieces and other chemicals. We then put it into this instrument here, and it can actually make identical copies of the DNA that was originally in the sample, allowing us to use a small amount of sample and get a DNA profile. This is a 4-capillary instrument, which basically means it can run 4 samples at the same time through different channels. When it's completed running, we have a computer software that will convert what the instrument sees via laser to a data form that we need to analyze it.